Okay, I have started streaming one more time. Okay, I hope now you can see everything. Yeah, I think now you can see everything because I can see it as well. Can you hear me? Because that would be great if you can also hear me well. Yeah. I think now everything is fine. So I will start the lecture right now. So the lecture is about slow queries. And the story will be about optimal server and database configuration. This is what I'd like to cover today. So my name is Damian Widera, and I've been MVP since the year 2009, so it's actually more than 10 years right now. I work for a company from Poland which is called Uvik, and also I do blogging. I have my own blog on codingfamily.net, and I do the blog with my daughter, and she is very keen about programming. She is 16 right now, so we try to run the blog together and have a lot of idea how the blog should go on in the future. And believe me or not, but 11 years ago, me and my two colleagues, we actually wrote a book about SQL Server. And yeah, the book is kind of outdated right now, but as it is the only book I have published so far, I proudly showing the cover on all my slides. But let's go to the details. Why it is really important and tough task to make sure that your queries are actually running fast. Because um, when you have an application and you have users and you can see the users on your right hand side of the screen, they should be happy. But from time to time, and I should say all the time, they are complaining because from their perspective, what they see is that the application is slow. So they are pressing some button, they do filtering, they do search, and they are waiting. And most of the time, you will hear that this is for sure, this is a database fault. And here is where actually the task, how to make your query fast, becomes more and more complex. And let me explain it to you. First of all, we have something on our server which is operating system level. And right now it can be both Windows or Linux. It's not on SQL Server can run on Linux right now. So that's first part when actually can slow down your queries. Then you have SQL Server installed and you have a lot of options and you have to take a look into those options as well. Then you have database. You can have many databases installed on one SQL Server. And each database can have different options. And some of the options should be checked because of the best practices. And then you have query. Then you can tune your queries. And the problem is, and the case here is that you should not start with tuning your queries. Because from my experience, and I have 20 years of experience, is that the query tuning should be done at the very last. So we should concentrate only on a very specific part. What you see on the screen is actually your server. It is SQL Server installed on some box, but it's not enough. Right now, we live in a world when we have a lot of virtualization and a lot of containers. So your SQL Server can run on containers. So you see that from this part, this is another layer which you should think we should consider, because it could be that it introduces also a performance problem. But this is still not enough. We have still more and more things to cover, because there is also an infrastructure layer, especially with the I/O subsystem. So it's more or less, it's all about disk and how you configure this layer as well. So this is complicated. We will concentrate only on It's a huge part, I mean, SQL Server options and database options, because everything else should be done by, let's say, people who are responsible for operating system. So, for example, system administrators, they should check whether the system is up to date. If you have all security updates, all patches installed, then you could have virtualization admins. They should make sure that your virtualization host is configured properly. And then you can have also infrastructure admins, and they should make everything correct to the I/O subsystem configuration. So it's a lot of things that should work together properly to make sure that your queries are actually fast. But from my perspective, if you concentrate on the options of SQL Server and database, then you can really do not touch the queries and make them fast. And take a look how to do this. So let's start with the real topic. And of course, I have forgotten that your server can be in the cloud, which is right now the best option. So you also have to be able to measure what is the latency between the application and actually the server, because this is also which can be seen from the user perspective, from the end user perspective, as slow responding server. Okay, let's start with very basic thing. Do we have a lot of data? I will show you one screen from SQL Server which presents how much data do we have. And I will, of course, I can read it from the screen how much data this actually database have, but I will make it easier for you. And you see from this screen that this database, that was the database installed 7 years ago actually, and it had 200 gigabytes. But you know, the number 200 gigabytes, it could be more. You can have bigger databases, you can have smaller databases. But think about it, that this 200 gigabytes was, was generated in the database after 2 months. And it was 7 years ago. So right now, nowadays, we are not talking about gigabytes. We are thinking about terabytes, we are thinking about petabytes of data. And still, your server, your queries must be very fast. So that's one thing. The other thing is that I have a question for you. What is better for performance? Imagine that you have two tables in your database. Those tables are small. So one table is like 10,000 rows and the second table is like 2,000 rows. So we can say they are so small that you can almost memorize the data from them. Yes, if we think about how small they are. And you have to provide a result of a query which you can see on the screen. So you see that there are two tables. You have to join those two tables together, and you have to provide information from two columns. The question is, first question is, how many rows should you expect? Should you expect 10,000 rows or maybe 2,000 rows? Or maybe you can expect only one row, or maybe 0, or maybe 2 millions, which is also possible. And the answer is, I have no idea, and no one knows. So we don't know how big the data set will be, because it all depends on the data and the joining condition. But my real question is right now, where should you do the operation? Should you do the operation in your application, which means you get data from table 1, you get data from table 2, and you perform the join in your application? Or should you do exactly the same, what I have just described, in a database? What do you think? Of course, you know I'm a database guy, so you know that the second option is the only true one. So we measured that actually, and the first option took almost 13 seconds. And the second option, without any tuning, the same query, but it was executed in the database, on the database engine, it looks like this. So you see the difference. So in my opinion, the database code should be run in the database. This should be your general, best practice. However, it's still possible that you can you can still have some code in your application and run it from the application, but you should do it right. But how to do it right is a story for another meeting. Yeah, you should always be care what you do, because database perspective is different from application perspective, and you should think about it that database code belongs to a database, and maintaining such code is easier from the database. But let's move forward. Now I have another question, and I believe me, we have no more slides, maybe 5, but this is very important right now. What types of the data types do we have? So a data type, it's like an integer, it's like a string. This is data type. We can have float value, we can have characters, something like this. So those are data types. But how can we classify them? So I see that we can classify them in 2 ways. Those data can be relational. Data types can be relational. So you can actually establish relations between tables and on the given columns. So you can then say that, okay, if I have a relation, I can display data from different tables using usual joins. Yeah, it's easy. But the question is, how much data do we have in a relational format? And it depends, because you can have database which is pure relational, but currently, let's say in the year 2019, it's rather not the case, and it could be only 10% or even less. So what is the other part? So the other part is, of course, non-relational. But how can you see this? What is non-relational? And now on the screen, you can see something which is called XML. XML or JSON. JSON looks a little bit differently, but it's still very, it's similar concept. And XML and JSON can be tricky. They might be relational, but in general, they are not. So from in this, what I'm presenting on the screen, I could show you that I see relations in this fragment on a file, but you should not treat XML and JSON as relational data types in general. They can be, but it's not always true. The other thing is, for example, Excel file. You can have Excel and you can treat it as a file, because then how you can think if Excel is relational, how do you define the relation between files? How to do this? So of course, any file, so like an Excel, like a Word document, like a PDF document, those documents, let's say that way, they are not relational. And of course, at the end, we have pictures. And I'm showing you a picture like a photo when you see a big TV and a guy sitting with a glass of wine. But things are more, things are more important, because, for example, we have a lot of pictures like a medical documentation. For example, you can have medical documentation. You have to identify whether a patient is sick or not, just by identifying whether you see something suspicious on the X-ray, for example. So if you think that you can have millions of photos, millions of pictures, then you know that you have at least 90% of your data is non-relational. And this is the think about it that way, that okay, maybe relational engine like SQL Server is not designed for this type of data. And you might be true, it might be true. We have a lot of NoSQL, let's say, engine like MongoDB, document database, which is called Cosmos DB, for example, which you can have it on in the cloud. So there are options, but from time to time you still have to have non-relational data in relational engine, and you have to be able to make sure that you can query them effectively. And now I'm going to trick you. Take a look about that. What about geographical data? What about geography? Are they relational or not? How do you think? They can be both, or only in one flavor, relational or maybe non-relational. Take a look on that example. That's one table, and in this table you can see that this is a table that contains information about city, about address, and some province ID. Province ID is like a county, and you have also a postal code. So I can have another table which gives me insights about what exactly state province ID means. So you see clearly how the relation looks like. I'm joining the table on the state province ID column, so I can get more insights about what, for example, state province ID 79 means. Yes, for example, it means that it is from Washington. And I have another information about, for example, territory ID. So I have another table which says that territory ID 5 means that it is Southeast US in North America. So you have a lot of information in relational format. So let's try to ask some questions right now about the data. List all streets from a given city. Okay, it's simple. I have all information in one table. For example, if you ask me about Bothell, I have information in the address line column. Very simple, very easy. But let's go further. List all cities from Wyoming. Yeah, that requires join between two tables, and I can show you those two tables. So you see, I have Wyoming. So Wyoming is actually number 82. So I would need to point back to the table with addresses, and then filter out state province ID with this 82 number. So it's a relational format. Okay. What about the next question? What are the streets between the street La Paz and Ellis in Bothell? Yeah, now we are doomed actually. Because take a look what the table has. I have La Paz here, and so the key number is 13, and I have Ellis, which is key number 16. But does it mean that only Book Street and La Vuelta, those are the streets between La Paz and Ellis Street? Probably not, because this is how the records are stored in the table, but this is not the representation on the map. So from this structure, I'm not able to answer to this question. And again, what about a question like this? This is the last one. Who lives close to 4912 La Vuelta Street in Bothell? So you have this street here. How to say who lives close to this street? Maybe you can answer the question because you have also postal code, you have city, you have address. So based on that, maybe you can have some algorithm, or you can use some you can put it to the map, Bing Map or Google Maps, and you can have the answer. But from your data in this format, you have no idea how to answer the question. So you see, things can be complicated. Okay, so now let's go and let's check the options. Let's start with server options we have, because there are some that you have to be aware, And let's try to analyze those options to make sure that, and I try to also show you the impact of each options. So first of all, it's one of the options that is responsible for making sure that SQL Server can actually run queries in parallel. Well, almost all servers, I should say all servers I work with right now, they have more than one core. So you can have one physical processor, but with many cores, and then you can also turn on hyper-threading. So for example, very typical situation is that you have one processor with 4 cores. With hyper-threading, you have effectively 8 cores. So the question is, why should we set setting what we would like to do is, maybe there is a way that that a single query can use more than one core. Maybe it can actually run faster. And that's the idea, and that the theory says that the more cores you have, the faster your queries should be. But you know, it's an ideal world, and the problem is that from time to time, I should say most of the time, it causes problem. So what you can do is that you can set up your max.dop option on a server level to some value. It could be 2 or 5 or 6, and that will restrict your query to run on this given number of cores. But if you set this option to 1, means that you are turning off the ability for SQL Server to run query in parallel. Sometimes it's okay, but this should not be your general option. And I'm talking about this on the first place because I have seen a server like last week, which actually has this option set to 1. And this server is slow. Actually, it's slow. So when SQL Server starts running it parallel, it say to you that, okay, I'm running it parallel, and it says it by setting a special flag which is called CX packet. So the CX packet means that SQL Server can run a query in parallel, which is not bad. But the problem is if you see that CX packet rapidly grows. If you see something like this, means that SQL Server has actually problem running in parallel. So the causes there could be a lot of problems regarding to that, but your action should not be to turn off the parallel query execution. Because if you set max.dop to 1, you will not see CX packet. So you may say, okay, I have no problem at all. Yes, you still can have the problem because your query can be slow. So you should not turn it off. But you should take a look into another indications of problems. And one of the indications, I'm not going to elaborate much on that, but if you see page IO latch underscore something, means that maybe your indexing strategy is wrong. And you have actually problems with some indexes on your tables, which result to your query, and the query is slow. I would like to show you what exactly it means that CX packet is a problem, and I will show you this. I will create a new worksheet, and imagine a situation like this, that this is your table. I will make it like this. It will be that big. Imagine that this is some kind of gigabytes. And you have 4 cores. So you have core 1, core 2, 3, and 4. And there is a very special, let's say, thread. We can call it this thread 0. Maybe I can even change it because then it will be easier for you to refer to the books, because in a book it is not called core, but it's called thread. So imagine that this is your table, and right now you have to read data from this table. So you see that you actually have 4 threads, and this table have 4 equal, you can divide this table into 4 parts. So actually thread 1 can pick that part, thread 2 can pick that part, thread 3 that part, and thread 4 that part. So you see each of those threads has equal work to do. It has to read exactly the same amount of data. So in that case, because you run this operation in parallel, so it could be from your perspective that it is done 4 times faster, because what is actually done, you will see that this operation is done in 1/3 of the time as if you would run the operation on 1 thread. And that's fine, that's how it should be. So the CX packet is actually started on thread 0 when the operation starts. So you see the CX packet is small. It takes some time, but it's small. But think about it right now, what can happen? It could be that for some reason your table SQL Server thinks that it can divide it into 4 equal parts, but for some reason it can't. And it could be that way, that 3 parts are really equal, but the 4th part looks like this. So you see that one thread has a lot of more work to do. So now if you try to group it into single point, so it looks that way. So you see thread number 1, 2, and 3 are already done. They have done their work. And thread number 4 is still working. So what we see is that thread 0 has to have a bigger CX packet, because the thread 0, the CX packet on thread 0 must be established for the entire operation. So right now it takes longer, but it's not enough. Also thread 1, 2, and 3, they have to also set the CX packet for the remaining part of the operation. So you see right now the CX packet takes this time and this time. And this is what I mean that you see that CX packet rapidly grows. Right now it's not like a single operation, it likes 10 times more, 12 times more, or even more. So this is indication of a problem. But what can be really the problem? So the problem, I should type it diagnosis. The problem can be, that means that the diagnosis said that, for example, you have a table scan, which means that you do not have indexes. You have also a lack of statistics. Sorry, it's in Polish, but I forgot to translate this one slide. So for example, you have bad indexes, bad query plan, lack of good statistics. That's the problem. So what should you do? You should make some administrative operation on your server, and probably it would be, first of all, take care of your statistics and of course about your indexes as well. And of course, do not change the max.doc to 1. Let's try to fix something else and then try to observe. So more information is that how it happens is that if you go deeper into SQL Server, you will see that each task that should be done can have some kind of status. The first status is that the task is suspended. So you would like to do something, but you are waiting for resources. The resources, for example, you'd like to access the disk, but someone else has the access. So you can find information in the sys DMOS waiting tasks. This is a system view. Then you have resources, but you are waiting for processor. And this is so-called runnable. So you are almost running, but still the processor is not ready for you. Some other task is running on the processor. And then you are actually running. So the processor says, okay, now we can go, I'm taking the task and I'm running it. Okay, so this is how it works. So this is another setting, and I will show you both of them in a moment, how to configure them, because the max DOP, so max degree of parallelism, is also tightly connected to cost threshold of parallelism, which means that SQL Server has some internal threshold, and it says that, okay, if a query is cheap enough, so you can say cheap means in that case simple enough, so maybe it's not worth to run it in parallel. So it must be a bigger query, so I can think about that I should try to run it in parallel. So there is a number which is by default set to 5. And right now, this default settings is not enough. So right now, most of the time, almost all queries has the number greater than 5. So in order not to make SQL Server running all your queries in parallel, or trying to run all your queries in parallel, you should change the settings to some higher number, like 25, 50, or 100. And I will show you right now how to change it. And the reason I'm showing this to you right now is that most of the time, when you install SQL Server, you are just install it and you are not configuring it properly. And the configuration, the default configuration of the SQL Server, it is okay for the development server. Yes, most of the time it will be fine. But it is not enough. It's bad for testing, it's bad for production environment. So you might ask the question, so why Microsoft cannot prepare a good installation with good options? So I ask you then, what are the good options? Tell me, what are the good options? You can have many servers and each server can behave differently, because it all depends on the workload, of how many databases you have, how many users work with the server, what type of the workload it is. Do you mostly write the data to the database, or you have maybe some analytic database which mostly you read from the database? So what are the good settings? They are no good settings. You have to configure it. That's why it's so important to know where to do this. So those two options I have mentioned, you have to connect to the server, and I should start something like this, that I'm using SQL Server Management Studio. You can use Visual Studio as well, Visual Studio Code, whatever application you use for connecting. And take a look. I'm connecting to my SQL Server. It's 2014 actually. And what can I do? I can go to properties of the server. So you see, this is the server setting, and I can go to the properties of the server, and then I go to the advanced settings. And in the advanced settings, down here in the very almost, those are the last settings, you see that I have max degree of parallelism set to 0, and that's good, because that means that SQL Server tries to do the best work and to find the best number of threads that should be assigned to each query. So I'm leaving it to 0, and this is the cost of parallelism. So I can change it to 50. Yes, and my queries will be some of them will not be run in parallel at all, because they have lower cost of the query. And I show you the cost in a next example. You see how to read the cost. So, but the question is, okay, I have this max degree of parallelism set to 0, but I want to control it somehow, because maybe SQL Server, most of the queries are working fine in terms of parallelism option, but I have one or two which should be configured better. So then you can really control how many threads can be assigned, and this is a special hint you can do on a query. But as it is not a setting, it is not a talk about how to tune a query, I will leave it for the next time. But you can control the number of threads assigned to a query on a query level as well. So now I'm changing the settings. You see, it was pretty quick. Let's go back to another settings, because right now we have something which should be obvious to you, that you can control how much memory SQL Server can use. Is it obvious? Of course. So why don't you set it? And I'm talking to you, not you personally, but to all people who actually should change the settings on a SQL Server. And because most of the time you see the default options, and the default options are bad. Because what is the minimum and maximum amount of memory for SQL Server for your installation that it's it's enough to operate with predictable performance? This is something only you know, not Microsoft or any other company. So that's why you are responsible for the settings. So take a look. You should set up both minimum and maximum server memory. It works that way, that as you know, SQL Server works on some operating system. So if you don't set this value, so then then operating system can ask SQL Server about memory for different reasons. It can. But if you set minimum and maximum server memory, then SQL Server takes the memory within that range, and it will be very unlikely that SQL Server is going to give the memory back to the operating system. So that should be that. This is the desired configuration. This is extremely important. It's not very important. It's extremely important in the virtual environment. If you run in virtual environment, you know the memory is very precious there. So you have to make sure that your SQL Server has enough memory to operate on any condition. Because if you don't set these values, then the virtualization host is going to take the memory for further use. And it is very tough to take the memory back from the virtualization host back to the virtual machine. So the best practice is, okay, if you have some amount of memory allocated to the machine, to the server, leave from 2 to 6 gigabytes for the operating system. It should be enough. Whatever you have, the remaining memory, give it to SQL Server instances, because you can have more installations of SQL Server on one machine. Typically you have one, so then if you have memory, give it to SQL Server, because it should use it. Yes, that's the memory you would like to have assigned to this machine. Okay, now so I will show you where it is. So back to the SQL Server, if we go to the properties, then we have memory options. And take a look. I have a very default installation. So let me, maybe I will be able to make it a little bit bigger for you, because the options are maybe not visible in the best way. Take a look. I have a very default installation, which means that minimum server memory and maximum server memory, they are not set at all. So in that case, SQL Server will be fighting with other applications, with operating system about the memory. I know that I have 32 gigabytes on my machine. So okay, 2 maybe 6 gigabytes should be left to operating system. So I can do something like this. Let's allocate minimum 8 gigabytes, and let's try to do something more like 16 gigabytes, or it should be okay. I can type 18 gigabytes. In that case, I make sure that SQL Server will never go below 8 gigabytes and should never be above 18 gigabytes. So you have very predictable situation right now in terms of performance, memory allocations and performance as well. So that's very good. That's actually very good. So right now, let's go to something which is, it's also a configuration, SQL Server configuration. It's about a database which is called TempDB. TempDB, it's a system database, a temporary database, and it is only one per SQL Server installation. You can have many, user databases, but you can have only one TempDB. Each of the user databases can access TempDB for different reasons, and most of the time they creating just temporary objects, sometimes some temporary tables. Usually they are small, so there are a lot of small objects there, and the problem with this is that the default configuration is bad as usual. So the default configuration says that you have only one data file and one log file, log as transactional log file, and within this configuration you have a lot of small objects. Now imagine a situation like this. This is not unusual. You have 64 cores. It's very typical right now, and you have very heavy workload. So you can have thousands of users which are playing with application, and the application requires to create some temporary objects on the TempDB. So 64 threads in the same moment are trying to hit one data file, and they get blocked. Only one of the threads can access the file and can put some information in it. So the remaining users, the remaining threads have to wait. And this could be one of the reasons that your query is slow. And this is some called resource contention, and there are some more technical information when the contentions are. And the solution is, okay, if you have 64 or 64, maybe it's not, it's a bad example. If you have 8 cores, then create 8 data files. So each core will use one data file on TempDB. So in that case, think about it, that from that perspective, you will have no contention in that case, or you will reduce the contention possibility, and your database will be, your queries will be faster. But have we changed the query? No, we have not changed a query at all. We are changing the configuration of temporary database. So Microsoft recommends that you create exactly the same number of data files as the number of cores you have. But if it is, it's a recommendation, but if you still see that the server is slow, you can, for example, add 2 more files. If the server is better, operating better, but it's still slow, you can add 2 more. And you see that at some point the performance is okay, and you should not add more. But if you add more files, for example, you have 8, you added 2, and the server becomes very, very slow, then you have to take back those 2 files and you subtract 2 files. So you have 6. If it is better, you go to 4. And just by experimenting, you have to find the proper setting in that case. There is no one good strategy. The good strategy, it's Microsoft's recommendation. It should work, and most of the time it works. Okay, then another part, which is called instant file initialization. This is also administrative topic, but it could be that imagine that you have a database and you have created the database that way that you have allocated a size for your space for your data file, and this data file has no room for new data, so it has to grow. So the growing operation actually can take time, and you can make it faster just by turning on a feature which is called instant file initialization. It requires to have some permissions on a server. So the permissions is perform volume maintenance task. That's one of the permissions. And the second thing you have to do is you have to restart the SQL Server. But then if you do this, then your growing operation will be almost instantaneous. It will take less than milliseconds, no matter how big the grow should be, because it's only allocation. Allocation means that the allocated space does not have to be filled with zeros. This operation is called zero. You have to zero out the file. So instant file initialization skip the zeroing part of the allocation. That's one. So that's typically, so you know, how you see this, that this is really a problem. It could be that from time to time you see that random query is very slow, and it happened very randomly, sometimes in the morning, sometimes in the evening, sometimes in the afternoon. It happened on one machine, on one laptop, but other people can't see this. So it is very random in nature. So it could be one indication. Maybe we can fix it that way. Then what else you can have? You can have a lot of indexes that are not used. Well, this could be a problem because typically indexes should speed up our queries when you read data. That's one of the things we are using indexes for. So if you have a lot of indexes that are not used, then it could be a problem, because that means that this index actually slowing down your queries because you have to maintain it. And I will give you some hint how this could be. So there is a very simple query, like you see, it's a system view, and then I can run it. But the question is, what does it mean that the index is used or not? So the index is used when you see situation like this, that I have a lot of read operation like this. This is, let's say, this is a read operation, because you can have three types of read. This is also a topic for another story. But if you sum, for example, if you sum all those three values, it should be higher than this value. So if we find an index that have only updates and have no reads, like this one, take a look. This one, this index is only updated, so it has to be maintained, but it is not used by any query. That it should be removed. It is not be possible because this is index 0. Well, it's also another story. You cannot remove it. But if you find any index which is greater than 0 and has more updates than 6 scans or lookups, that means that this index is not used, and you should remove it. And of course, you can see many bigger values like this. And this is really important because you can have hundreds of not usable indexes. Why should you keep them? They are slowing down your system. Okay. Now this is one of the options, which is called Freelunch. You know, Freelunch means that you have something, you have a setting which gives you the only benefits without any drawbacks or side effects. So the question is why it's not always turned on. And my answer is I have no idea. This settings is turned off by default. So you should turn it on, because what the settings is doing, maybe I can demonstrate it. It is protecting your server, especially the region of the memory, the region of memory is called plan cache. So you can imagine that your memory, available memory, is divided into some parts. So one of the part is for data, but another part is for plan. And I will show you the plan. What I'm doing right now is I'm cleaning up the server memory. So whatever memory I have in my RAM, right now it's turned off. I mean, it's cleaned out. So take a look. what do I have in my cache? In my cache, I have actually two plans because I have run a query. So each query has to produce a query plan, and I will show you how it could be. This is the settings which is by default. So the optimization for ad hoc workload is set to 0. Ad hoc query is the query that you run maybe once and you will never run it again. So it is very, this is a query which is very random occasionally, but it has to generate a plan, but the plan will never be used. So it's like a garbage. Why to keep it? Yes, that's the question. So the default setting is like this. And take a look what we see. I'm switching to one of my databases and take a look into query. Take a look. I have 7 queries and you can say, okay, those 7 queries are almost identical because the only difference is the filter settings here. So I'm filtering the table dim currency by currency key and I'm just changing the numbers. So I'm running the query 7 times and I'm going back to check what is actually in my buffer. And take a look. Each of the queries produced a query plan. And the query plan is actually 16 kilobytes. You think, okay, 16 kilobytes, I have 128 gigabytes of memory. Who cares? You are wrong. This is the one of the also performance issue you can have. Imagine that you run a lot of ad hoc queries. You can have thousands of them. What's more important, your code you are running from application will be treated as an ad hoc query. So it will materialize the plan, the full plan of a query without any need to do so. And I'm showing you one more thing because I told you that I will show you the query cost. Take a look. If you go there and you select execute a query to visualize a query plan, take a look on the select statement. I can see estimated subtree cost, and you see 0.003. So the query is simple. The number is less than 50. So if this cost is higher than 50, because that's my setting, then SQL Server would try to run it in parallel. So that's the setting. You can set it here. So that's how I generated the estimated execution plan on a query. Okay, now let's take a look how much memory I use. So it's not that big. I have 10 plans. It's like less than 200 kilobytes there, but I can change the behavior to the desired one. So let's change it. Take a look what we can have. So I'm changing the optimize ad hoc workloads to 1. I'm cleaning the cache and I'm running the same query. I will still have the same number of plans, but take a look right now how the plan looks like. It is not 16 kilobytes. It's 128 bytes because it's like a stub. It's like this is only like how to say, like a pointer to a plan. So the plan will be generated later. If I run the query one more time, right now you will see that some of the plans, you see, this is the plan that's been generated, for example. That's the full plan. You see, it's called compiled plan. It's called compiled plan right now. So after second execution of ad hoc query, SQL Server thinks, okay, maybe now you will use it. So you see, this is the difference. And if you still think that the number are not too impressive, imagine that is actually 100 times smaller than that. Yes, so if you multiply something which is smaller 100 times, means that you are sparing 100 times memory for your cache. Okay, let's move forward because we have still some options to talk about. So this is what I explained already to you. You should do this. This is very good option. The one option which looks like it's a good option, which is actually wrong one, It's called priority boost. Whatever you set in SQL Server 2016 for this option, if you turn it on or off, it doesn't matter. But if you have older SQL Server like 2008, 2012, it still matters. So remember that this option should be turned off, and by default it's turned off. And to make sure that you are not going to turn it on, I'm not going to show you where it is. So it will be up to you whether you would like to find it or not. Okay, let me go to another things, because right now we have database options, and those database options, let me go through them. I have demos for them, and I try to show this to you, this is very, very important. Let's start from data files and log file. As you know, SQL Server database can by default have one data file and one log file, and that could be fine. Why not? But the problem is that if you put them on the same disk, then you will have serious performance problems, because you can see that data files typically have the ratio from read to write operation is that for 3 read operation, typically we have 7 write operations. Of course, the numbers can be different, but this is the most typical settings, the most typical workload. Log file can only write data. So you see, when you place them on the same disk, when you read data from the data file, you can actually block logging. And that's really a problem, because that also can cause queries to be slow. So what to do? Well, separate them. Put one disk for log and another disk for data files, and you have solved the problem. And the indication how to find out that something is slow is take a look for so-called stall time. It should be measured in milliseconds. And the number is that if you stall time, so stall time is how long do you wait for accessing the disk. So if the time is greater than 20 milliseconds, then the system is slow. If it's greater than 50 milliseconds, then I say that we as a humans are faster than a database. And to tell you that this is really a problem, I will show you actually, this is the diagnostic results I did last week for one of the customers. Take a look. This is 3 seconds. Each query was, by average, had to wait 3 seconds from this one database. This is 700 milliseconds. Do you think they still have database, or this database is performing well? No. And the reason why is that everything is on the default location on OneDrive, apart from one database which is not used by it's turned off. But all other databases, they are put on the same disk. So log files and the data files are in the same location. So for each query is by default has to wait 1/10 of the second. This causes massive problems and massive issue. The solution is simple. You have to buy another disk and change the configuration, and your query will magically be faster. This is how it should be. And if you are curious how I produce this very good Excel sheet, I will show you how to do this. You should go to SQL Skills, and you should find Glenn Berry. Glenn Berry is also he's a former MVP from SQL Server, and each month he publishes actually a set of diagnostic queries. So you have queries, and you have this fancy Excel spreadsheet. So for example, if you have SQL Server 2019, you can open the queries, and you see that you see this is the code. There are like 70 or 80 queries, and this is used for diagnosing the SQL Server, whether it's configured properly or not. So one of the queries was about the stall time I have shown you. So you can use it for free. You can use it for free, and this is a very good starting point for the configuration. Okay, let's move forward. Log file, we have one log file, and actually this one log file is internally divided into smaller virtual files. So the virtual files should not be, you should not have too much of them or too many of them. And typically we say, okay, if you have around 100 virtual files, it's okay. If your database is big, like 350 gigabytes, you can expect that 400 virtual files are still okay. But if you have situation that you have too many small files or few big files, then this is also actually not good, because that could slow your transactions down. So you can have problems when you have to do a restart or restore a database or start the database. You can have problems then. You have to also remember that we can actually read it, and I will show you how this dbcc log info works. And also important information that there is a new algorithm, and you can find the algorithm, how it works for SQL Server 2014 and newer when you read this blog post. But by default, how many files do we have? So if our database is really small, it's tiny, like it has 64 megabytes or less, you will see that the virtual log file, the log file can have up to maximum 4 files, and it will have 4. If your database is up to 1 gigabyte, it will have 8 files. If the database, this is the most typical situation, is greater than 1 gigabyte, SQL Server is going to create 16 files, each 1/16 of a database size. So that's how this algorithm works. And I would like to show you that this could be a problem for you, and I would like to show you that it could escalate pretty quickly. So the number of files, you can see them very quickly growing. So let me create a database. This is a database which is called log test. I will change so-called recovery model to simple. That's just to make sure that the demo goes as I expect, and I can explain you the behavior. Typically, is not the setting for production, which complicates the solution, of course. So take a look. I'm having this my log database. It's small, and I have one log file, and internally this log file is divided into 4 smaller files. 4 smaller files. So I'm creating a table, empty table right now, with only 2 columns. And you see that I have created a table and nothing really happened to this log file. Yes, good. Right now I'm inserting 40 rows. Let me do this. Let's check if we have something in the file. So you see 40 rows already generated some information in the log file. So try to think about what is going to happen if I generate 40 rows more. So we actually have 2 options. The log file, the virtual file number will be growing, so I will see more than 4, or something else is going to happen. So let's see. And you see the log file has not grown, and it is because the idea is that if the transactions are no longer needed and you are in the recovery simple mode, then you can overwrite the data in log file. So in that case, you see that the log file is not going to grow. It will be like a circular log. But what happens if I'm going to open a transaction? And with this transaction, I'm inserting 40 rows. Let's check if we see something unusual in the log file. No yet. So let me insert again. We are here right now. You see, we are here. That's the sequence number. So we were here, 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 and we are back at the beginning of the log file. But take a look what's going to happen now. Do we have enough space? The transaction is opened. I cannot overwrite it in the log file. So I have to grow. So take a look. I was there, and I know that I have no space here for the actually for the rollback of the transaction. So I have to allocate a new file, virtual file. And this is actually, let's call it a timestamp. It's not a timestamp per se, but we can understand it that way. Let me generate new 40 rows and take a look. You see how it actually very, very fast escalating. The log file is growing, growing, and growing. So it can be that if you are not maintaining it well, the log file will be growing. So I'm committing the transaction and take a look what's going to happen. It will stay the same. So it grown, and it cannot be shrinked automatically. It can be shrinked manually, which is one of the options, but shrinking is not the preferred way. Yes, you should forget about shrink as an option. Okay. Now I will show you one more thing. It's about auto growth. So the default settings about auto growth is wrong, as everything in the default installation, because the default setting says that the auto growth operation should be every 1 megabyte for data file and 10% for log files. This is wrong. Those settings are derived from system database, which is called model, and you can change it there. So every new database will have different options. So right now you see that let me go to the demo, because you will see this on the demo. It will be visible why it's so bad. The reason for this is that we can have a lot of options here, and this operation actually is not the auto growth operation takes some time. The more operations you have like this, the more time SQL Server consuming on managing, growing, etc. So it's that's the problem. That's the problem in that case. So take a look what we have. Now it's almost 9, so I changing to 21. So I'm creating a database which is called test. And the test database, it's as like previous time. So take a look. I'm creating a table in it, and I'm inserting 2000 rows. And this, you saw it was like 1 second, but it was slow. And take a look how many auto growth operations do we have during that time on that database. Actually 20. So the database has to grow 20 times to insert 2000 rows. It's crazy. And this is really something that can slow down your queries. You know that the operation was not taking so long, but your file is hugely fragmented, and it has to be maintained by SQL Server in that case. There is another problem which I would like to show you also right now in the second demo I have. So take a look. I'm creating right now a database which actually has two data files. So from that perspective, how SQL Server works is that those files, they should grow, but they should grow together. It should be that when one file is growing, the second file is growing too. This is because how the data is then distributed across the files. And the distribution is called round robin. So the SQL Server tries to fill out the data proportionally in each file. So if one file is bigger and the second file is smaller, the bigger file will be accessed more frequently, which makes the file to be hot actually. So we try to grow the file automatically in the same way. This is so-called trace flag. From SQL Server 2016, you don't have to care about it. But we still have a lot of older installations, and I'm going to demonstrate what is going to happen when you don't have this trace flag set on. So I have created a database with 2 data files. I'm using the database right now, creating a table with 3 columns right now. It's not important. And take a look. I'm inserting 1000 rows to this table, like this. And then I'm checking what is the database size. And take a look. One data file has 6 megabytes and the other have only 5 megabytes. So after first operation, first insert of data, what you actually see is that in that case, your files are no longer of the same size. Yes, and you see by the same idea that I will show you that it's actually not growing in the same time. Take a look. The log file has to grow many times. You see, we started here. This is when the data file actually has grown. You can say, okay, it took 3 milliseconds. Should we care? Yes, we should. Yes, we should. From time to time, it will not take 3 milliseconds. How can we fix that? In older version of SQL, so 2014 and older, you have to set trace flag to like this. In that case, when I repeat the operation, so let me just drop the database and recreate it one more time, exactly the same thing, exactly the same things. So I'm creating the database, creating the table, inserting thousands of rows and showing you the results. And take a look what we have right now. So right now you see those files are equal. So we have fixed the performance problem, possible performance problem, and take a look how it works. Take a look how it works. So you see we started somewhere here, log is growing. Then one of the files started to grow and it triggers in the same time. You see it triggers in the same time. Ending of this operation trigger this operation. So in the same time we have grown the data file like in parallel. So in that case, those files are equal. Of course, you have to set the values. What is the growth? The growth should be also set up properly, not by 1 megabyte or other set. Okay, I have few more slides. One, there is an option which is called auto shrink. It should be turned off always. You should never ever turn it on, because I don't know why the options is still in SQL Server. It's a good question, but it's still there. It's still there. It's not been removed yet. It causes a lot of problems. It has no benefits. I could tell you about one, but no. Let's remember that auto shrink is a pure evil. It's a pure evil. You should never turn it on. Because what it tries to do, it tries to shrink down the database files. Means it tries to get some space from your data file and from your log file. No one knows why, but it can be that this is the settings. It works that way. So you have no control when the shrink operations start. So it's random. So you see, you can have also your query running, and out of a sudden, one of the query is slow because auto shrink has just started. It consumes a huge number of resources on a server. It's terrible. And it also causes huge fragmentation on the indexes level. So it has only drawbacks, no benefits. It is still there in SQL Server as a database option. If you are curious, I will show you the option where it is. But please don't touch it. So let's go to one database we have. And you can go to the options and you see there is the option, it's called auto shrink. I have turned it off by default. And please leave it that way. The other option I'm going to mention right now, it's not so evil, but it's still bad. It's auto close. It should be set to false, as you see in my database. By default, they are turned off, both of them, and you should leave them that way. So auto close says that when there is no active connection to the database goes offline. And the bad thing is that it's turned on by default in SQL Server's Express edition. So if you use this edition of SQL Server, it's free, then you have this option turned on by default. So you have to go and turn it off on all databases in that case. So when your database goes offline, when there is no active connection, you can think that, okay, when there is a new connection, I have to make my database online again. And the process turning on database can take time. And in worst scenario, worst case, it can cause a timeout to your connection. And of course, from time to time, it has also negative impact on the server. So that was actually all. And those were the most important settings on a database level, on the server level you can have. You should follow the best practices because setting them, they will not cost you anything. It's only your knowledge and your best practice. So why should not follow the best practices if you can? Because it could be that you do not have to fix your queries at all. Just make sure that configuration of your server and your database is proper. And this is the last sentence I would like to say, because I would like to thank you for being with me for the hour. If you have questions, you can post it right now on the chat, and I try to answer them. Thank you very much for your patience and be with me here. Thank you.